Okay. Greetings, friends. The reason for this video is a week ago I saw John posted from Cadence. New customers are switched to Cadence because we enable them to make PCB symbols and connectors in a fraction of the time. Okay. Cadence, as we all know, is not free software and relatively expensive, unfriendly software, if you ask me. Okay. And he posted a video of that. We'll go through and we'll look at the video. I'll stop the video. Okay. The man starts off at Samtech site, creates a step file, imports your step file, selects the plane, creates SMD, starts to number the SMD, adds his silk. Okay. So my comment, I answered him and I said, congratulations. Okay. And I sent a video, answered him with a video of how Maurice did it, and Maurice did it just over 2 years ago. Okay. Maurice is the person who created the StepuP add-on for Freecad. Okay. However, Maurice didn't explain very well the steps and didn't go through it step by step that any idiot would be able to understand how to do it. Okay. So I'm going to go through the steps. I'm going to go through the steps of doing this. Okay, displays, swap displays. Okay. Where do we start? Okay. He started at Samtech. I'm starting at 3D Content Central. Reason I'm not starting at Samtech is because I'm not a member. I'm not signed up at Samtech as a member. Well, I don't remember my username for Samtech. I'm starting off at 3D Content Central. At 3D Content Central, I download the step. Okay. What I've done now is I have the step opened up in Freecad. The orientation of the step is not correct, because when I'm on top, I'm looking on the right. So instead of starting to play around to manipulate the step, I changed my my viewing position. My viewing position is on front, so I'm looking straight down at the pads. I need to be either from front or back. I need to be straight looking at. The way this works is I need to be perpendicular to, my view needs to be perpendicular to the pads, or the way that the part is going to sit on the PCB. Okay, I've now moved my workspace in Freecad to Kicad Step Up. Okay, I'm clicking on this icon. Here it is in the palette. This does a copy of the original step in a way that I can edit it. Okay. Next step, I get rid of the I block out the original step, and on the copy I click on this icon. This icon creates a 2D drawing from what I see on the screen. A 2D projection. As I was not looking at it from the right direction, I'm looking at it from front, but my 2D projection was from top to bottom, so I need to go change my viewing angle. And now I'm looking down top to bottom on my 2D image, which has been created. After the 2D image is created, I press these arrows. Here it is in here. It creates from a 2D view to an editable sketch. An editable sketch means that the sketch can be parameterized. Okay, so now I have a sketch. I have a sketch of my part. Okay, I do not know if the sketch is valid. Okay, if I'm going to Kicad, I open up the Kicad template. I open up the Kicad template and I change the name of the converted sketch to the layer I want it to be. For me, the best layer is the fab layer. The best layer is the fab layer for me. Okay. Now, the next step is I check that all the lines are joined. All the lines are joined and no coincidences. Okay. A problem with when working with Kicad is that you require coincident lines. The same holds true to Altium. The same holds true to Altium. For example, if you don't have a full outline in Altium of your board shape, Altium will not be able to know the board shape if you have open holes in your in your outline. So very often when mechanical engineers export DXF files, they have holes in it's not one full continuous line. So here I'm running through and fixing the lines so that they'll be coincident. basically dropping off, connecting the lines if they are very close together. Okay, it is a problem with when working with DXF files exported from biomechanical engineers. Here too, it is also a problem. Okay, I create coincident line, coincident points. At this point in time, I press group and move the sketch into the group I've created. If I wanted to create pad shapes and other things besides having a mechanical layer with all the details, I would need to copy the information into a different sketch and delete all non-relevant data so that the pads would be able to be created. I personally prefer to put my pads in Kicad and not place pads here. It's just too much editing of the sketch, especially on 180 pin connector. I don't want to start editing the sketch to remove superfluous lines. Okay, so for me, I personally only use the fab outline layer. Okay, at this point in time, I can take the sketch and I can export it as a DXF, which in a tool like Altium, I can then import the DXF. Import the DXF, and from the DXF create my footprint. But that is if I was doing it within Altium. But here I'm doing it within Kicad. Within Kicad. Okay. So at this point in time, in my example, I'm only creating the fab layer. Okay. Okay, this is the wrong icon. This is the icon for import. This is the icon for output. So I press this icon for output and I give a name for a path where I want to store my Kicad mod file. Keypad mod is my Kicad footprint. Okay, I save it. Gives me an answer that it's saved. Okay, I've now left Freecad and I'm now inside Kicad footprint editor. I am importing the file that I created. And lo and behold, I have a fab layer. I have a part with a fab layer. Okay. As I didn't edit the sketch to make a sketch only of pads, I don't have the pad data. it's a lot quicker for me to take the information. So I start off and I go to the data sheet, and from the data sheet I take the parameters like what is the pad size, what is the spacing between the pad, horizontal and vertical, how many layers do I have, how many rows do I have. I have 2 rows. So at this point in time I'm creating 2 rows, 90 pads in each row, 0.5 millimeter in vertical, 0.5 millimeter in vertical, and my horizontal 6.2, which I was taken out of the data sheet. Okay, it could be you could also measure this, but to be more exacting, I took it out of the data sheet. Okay, next steps. This step I created. The previous step I created all the pads. I then copy from the fab layer, to the silk screen layer. I copy the silk screen outline. Note in this particular one I don't have if I wanted to create the pad data, I would have needed to remove all these lines, which is one of the reasons why I didn't do it. Okay, so I create my silk screen. I would move my reference designator outside, not underneath the part, and it would be J question mark, and value, more than likely I would create I wouldn't have the value printed on the silk screen on a real part. Okay, my last step in this example is to add the 3D model that we started with and edit the relevant information like solder mask expansion. Okay. Word of caution. A word of caution is that in general, your footprint size is slightly bigger than your physical pad size. So to copy directly the pad size from a step file is not overly advisable. You're better to take that information from a data sheet on what your pad size it needs to be, not not from a 3D model. Okay. Parameters that need still to be adjusted. For example, here in Kicad has a 5mm solder mask expansion as default. If I remember correctly, Altium has a 2mm solder mask expansion. So I reduced the solder mask expansion to 2mm in order so that I would be able to have solder mask between the pins. Okay. I haven't gone into other layers that are needed for footprints like courtyards and things like that, but they can all be derived from the information that you have on the fab layer in my example. Thank you, friends, for your time, and I hope this is useful. After this, I'm going to show how one can do it. That was all related to Kicad. I'm going to show how it is done. Okay, friends, we're looking at the sketch of the sketch of the footprint that they used in the Cadence example. And what I'm going to do now is I'm going to go File, Export, and we're going to call this Altium. Okay, I've created, accept this. Okay, I've exported this layer to a DXF. I'm now going to go File, Open, and I'm not opening the, accept the defaults. Okay, and I've now got the DXF information. I've now got the information in a DXF file. This DXF file can be imported into Altium, and one can easily in Altium very quickly create the silk by just moving lines from layer to layer. Very easily create silk, courtyard, all the layers for making a very quick Altium footprint. Okay, thank you for your time. The end.